So today we're going to start talking about how we justify problems that are already solved. So last class you talked about, or actually it's 2 classes ago, you talked about all of the different properties that you have learned. So today what's going to happen is I'm going to give you an example. I did not need to write on that, but I'm going to give you an example. Oops, sorry, hold on 1 second. Learning how to work machines. I don't have to. That would make my life a lot easier, wouldn't it? Undo, create pencil. There we go. So what's going to happen is all of these problems have been solved out for you, but you have to be able to give me the reason on how to solve, on why I'm allowed to do what I did. Okay? So I'm going to go ahead and highlight my title just like I do all the time. I'm going to go ahead and highlight my title. And then I'm also going to highlight my goal. Okay, because everything we do in this class, we have to have some goal. So this part of today's, the first part of this next unit, we're not solving anything. It's been solved. So my goal is to determine, a property that justifies the step of a problem. Okay? So my goal is to determine a property that justifies each step in a given problem. So if I were to look at these problems, notice it gives me the work that's already solved out, and then it has a reason blank. So how I solve this is I always start out by numbering my steps. So if I notice this is step 1, step 2, step 3, step 4. Because I have 4 steps, I'm going to be able to come up with 4 reasons. Okay? So that's number 1 that I always do is I number my steps. 1, to keep my thoughts organized. 2, to make it easier when your teacher's grading it. And 3, that way to ensure that we're trying to get these problems correct. So step 1, which is right here, that's the problem that's always given to you. Because in math class, we always have to give you a problem, like an example to solve, right? So step 1, no matter what it says, step 1 is always given because that's what's given to you. So now, if I look at step 1, what do I notice that changes from step 1 to step 2? What changes about those 2 steps? Well, I notice 9 plus b switches places. So what property allows numbers to switch places? Well, that's the commutative property, right? And that's the commutative property of addition. Okay, so step 2 is the commutative property. So now if I look at step 2 and I compare it to step 3, just if I erase this so we can see it. If I look at step 2 and going to step 3, how does it physically look different? Well, from step 1 to step 2, 1b changed from b. So that's how it physically looks different. Okay, so what property allows me to say b and 1b are the same thing? Well, that's the identity property. Identity property of multiplication. And if I go from step 3 to step 4, what happened? What physically changed? Well, I got a negative 3b, right? Well, how did I get that negative 3b? Well, that's because I added negative 4b and 1b, right? So there's no property for adding. That's just basic math. So I would just say I added. And I'm done. So because I'm able to justify all of these steps with a mathematical property, this is the valid way to solving the problem. So if I erase and we keep going and we look at the problems below, let's look at example 2. So the first thing I'm going to do with example 2 is I'm going to number my steps. 1, 2, 3, 4. I have 4 steps, so I better have 4 reasons. So if I look at this example, step 1, what do you always know about step 1? Well, it's given to me. step 1 is the problem that's always given, that's always printed on your paper. Okay? So now if I go from step 1 to step 2, what changes? Well, notice in step 1 I had parentheses, but in step 2 I got rid of parentheses. What property allows me to get rid of those parentheses? Hopefully you're all telling me it's the distributive property. And if I look at step 2, how does it change from step 3? Well, going from step 2 to step 3, 5z and 15 swap places, so that's the commutative property. And it's commutative, it's either of addition or multiplication. Those are your options. So since it's subtraction signs I can squeeze in addition signs, so it's of addition, because that's like saying negative 15 plus negative 5z. So there's like that invisible plus sign, so you don't have to do that. And then if I look at step 3 to step 4, what changed? Well, 7z minus 5z, that makes 2z. They combine like terms, right? So you can say CLT, or I was going to say they added. Okay? So remember how I get my justification is I'm always looking at the previous step to get my answer. So let's go ahead and erase this. And let's keep going. We have example 3 and example 4. I want you to pause this video and I want you to try example 3 on your own. And when you finish, unpause the video and we'll go over it together. So the first thing I'm going to do is number my steps. I have 4 steps, so I have to have 4 reasons. Again, why I'm doing this is to keep my thoughts organized. Okay, what do you always know about step 1? It's always given. Going from step 1 to step 2, what changed? Well, it looks like they distributed. So step 2 is distributed. Going from step 2 to step 3, what's changed? Well, 5 and A switched places. That's a commutative property. Commutative property of addition. And step 3 to step 4, they added. So go ahead and try example 4 on your own and then pause the video and we can go over it together. So I have 5 steps. Step 1 is given. Going from step 1 to step 2, what physically changed? X times 1 over x changed to 1. What property allows you to do that? That's the inverse property. Step 2 to step 3, what physically changed? 12 plus 1 made 13, they added. Step 3 to step 4, what physically changed? 4x and 13 switched places, so that's the commutative property of addition. And step 4 to step 5, they just combined like terms, so I added. So notice on all of these problems are expressions, they're not equations. So if you flip your paper, we have examples that have equations on them. And that's where we have to use what's called the properties of equality. So I want you to go ahead and take a second and highlight properties of equality. And then you're going to also highlight the borders of your boxes so your brain knows that it's important, except my highlighting looks like garbage. Let's try again. A little better. Okay. So I have 4 new properties that I have to add, but I promise they're not hard. Okay? So property number 1 is the property of addition of equality. So all this property tells me, the property of addition of equality tells me I'm allowed to add the same number on both sides of the equal sign. So I'm going to add any number to both sides of the equal sign. The next property is the subtraction property of equality. And I could say subtraction property of equality, or I could say the property of subtraction of equality, whatever you wanted. So subtraction property of equality is this when I can subtract any number to both sides of the equal sign. Okay. So the second to last one is the multiplication property. Multiplication property of equality. So multiplication property of equality is I'm just multiplying any number to both sides. And I just write both sides now, so you know that means both sides of the equal sign. And the last one is the division property of equality. So this means I can divide any number to both sides. So these properties only work when an equal sign is present. Only work with equations. Okay? These do not work if I have an expression. They only work if I have an equal sign. Okay? So, if we go ahead and we look at these equation properties, so these ones look a little scary because they're long, but they're not hard. So the first thing I'm going to do is number my steps. What do you always know about step 1? It's given. Going from step 1 to step 2, what changed? 8 and x switched places, so what property is that? That's the commutative property of addition. Going from step 2 to step 3, notice x became 1x. What property allows me to say x goes to 1x? That's the identity property. Going from step 3 to step 4, what changed? Well, 4x and 1x became 5x, so they added, or CLT, whatever you want to say. 4x to 5x, what changed? Looks longer because they added a minus 8 on both sides. What property allows me to subtract a number on both sides of the equal sign? Well, that's the property of subtraction, or the subtraction property. I'm going to call it the subtraction property. Subtraction property. I have to say the word property with these properties, so I know it's the subtraction property and not just subtracting. So now from step 5 to step 6, what did they do? Well, they did 8 minus 8 was nothing, it was gone. And 18 minus 8, well, that's 10, so they just subtracted. From 6 to 7, what's happening? Well, they're dividing a number on both sides. They're dividing by 5 on both sides. So that's the division property. And you can call it of equality, but all of equality means is it just has an equal sign, so you don't really need to use that. From 7 to 8, how did they get x equals 2? They divided because 10 divided by 5 is 2. And from step 8 to step 9, x equals 2 and 2 equals x. What property allows me to say that? The symmetric property. So you're going to go ahead and you're going to try example 2 on your own. And then you can check your answer with me, or you can check your answer on Google Classroom.